Now we know the definition of interference. When two or more light waves arrive at a point simultaneously, means if they cross each other, then there is a change in the intensity of light at the point of crossing. So the point of crossing will appear bright under these two cases when the two waves cross each other at that point in the same phase, and the point appear dark, distant to interval, when the two waves cross each other in opposite phase. So phase factor is very important factor. Now, when number of light waves are crossing at various points, then some points are bright, some points are dark. So what is the nature of the interference pattern, how the interference pattern looks, that we have to decide. So light waves are transverse waves. Water waves, waves produced on the water surface by dropping it from, they are also called as a ripple. Ripples are also transverse wave. So now we will decide the nature of the interference pattern, how the interference pattern looks. Nature of interference pattern. Nature of the interference pattern. And for that purpose, we are going to study a ripple time experiment. So ripples are produced in a tank filled with water. So separate question is given in our notes for this ripple tank experiment. So to decide the nature of the interference pattern, we are producing the water waves on the water surface by dropping a stone. They are called as a ripple. So I will draw the rough diagram here, and then accurate diagram we will see on this side. So suppose at point A stone is dropped. So if we see the water surface from side, then we will see this type of position of crust and troughs. But if the water surface is observed from top side, for example, if this is the water surface and stone is dropped and we are observing from this side, so we observe the circle, alternate circle. So in one circle, all the particles are going up. This is called as the circle of crust. I will show it by solid circle. Then next circle is a dotted circle. And again this is a solid circle. This is a dotted circle. So we observe alternate circles of crust, trough, etc. from point A where the stone is dropped. Now this is the crust, this is the next crust. So this distance is distance between the two successive crusts, and by definition it is the lambda. But this is R2. Now this distance between crust and trough is the distance is lambda by 2. So at this point there is a trough. So this is R1. So in this figure, R1 is equal to distance between the trough and next crust. So it is lambda by 2. R2 is equal to R2 is this is R1. This is R2. So R2 is equal to distance between the two successive trough lambda. R3 is equal to 3 lambda by 2. R4 is equal to 2 lambda. R5 is equal to 5 lambda by 2. Actually this is lambda means this is 2 lambda by 2. 2 cancel. This is 4 lambda by 2. 4 divided by 2 like this. R6 is equal to 6 lambda by 2. So that is equal to 3 lambda. R10 is equal to 10 lambda by 2. That is equal to 5 lambda. R17 is equal to 17 into lambda by 2 like this. So the radius of the circle of crust and troughs are like this. So R2 is double than R1, R3 triple. आणि हे सर्कल आपल्याला काढताना कशी काढायची नाही, तर ह्या सिक्वेन्स प्रमाणे काढायचे. फर्स्ट सर्कलची जी रेडियस आहे त्याच्या डबल सेकंड सर्कलची रेडियस येईल, त्याच्या ट्रिपल थर्ड सर्कलची रेडियस येईल, फोर्थ रेडियस R4 4 times R1 येईल, like this. So in this way we can draw the circles. So they are having same lambda, they are having same frequency, like this. Now nearer to the point A there is a B point. Where again a stone is dropped. So from this B point, again this type of circles are produced. This is the position of trough. This is the next circle, position of crust. This is next circle. This is next circle. This is next circle. Alternate crust and trough. So this is trough, trough, etc. So solid circle represent the circle of crust and dotted circle represent the circle of trough. So all the points, all the water molecules on this circle are in the position of trough. This is a concave part of the wave, and all the water molecules on this circle are in the position of crust. So they have gone maximum distance in the upward direction. These particles have gone maximum distance in the downward direction. So this is the position of trough. This is the circle of trough. This is the position of crust. This is the circle of crust, etc. So we get alternate crust and trough. Now see, in this figure there are so many points of crossing where the waves ripple from A and B, transverse wave from A and B are superimposing each other. Now we can decide the nature of each and every point of crossing, whether it is a point having constructive interference, maximum displacement, or destructive interference, minimum displacement, by using these rules. Same phase crossing, maximum displacement, opposite phase crossing, minimum displacement. आपण आता याच्यातला एक एक पॉइंट आपण कन्सिडर करू. फॉर एक्झाम्पल आता हा पॉइंट कन्सिडर केला, इथे दोघे सॉलिड सर्कल क्रॉस होतात. मीन्स द सर्कल ऑफ क्रस्ट फ्रॉम ए अँड बी आर क्रॉसिंग इच अदर. क्रस्ट म्हणजे ही पहिली केस झाली. So in this case the resultant amplitude is maximum. I will show this maximum displacement by circle. So at this point the resultant displacement is R is equal to A1 plus A2, maximum displacement. So the point of maximum displacement are shown by circle. Now consider this point. इथे दोघे dotted circle cross होतात. So trough of circle of trough from A and circle of trough from B, they cross each other. So trough cross each other means this is the second case. Trough cross each other. So again the resultant displacement maximum but in the downward direction. So again it is a point of constructive interference. It is shown like this. Now consider this point. Here one circle of crust from B and one circle of trough from A. So one crust and one trough cross each other. So in this case the resultant displacement will be minimum, and therefore these points of minimum displacement are shown by cross. इथे पण तेच होईल. One circle of crust from A and one circle of trough from B, they cross each other. Destructive interference. This is a destructive interference. This is a constructive interference. जिथे दोघे डॉटेड सर्कल क्रॉस होतील तिथे आपल्याला कन्स्ट्रक्टिव्ह इंटरफेरन्स मिळेल. सॉलिड सर्कल क्रॉस झाले तिथे पण आपल्याला कन्स्ट्रक्टिव्ह इंटरफेरन्स मिळेल. सो दिस इज ए डिस्ट्रक्टिव्ह इंटरफेरन्स. दिस इज ए constructive interference, like this, like constructive interference, destructive interference, like this. So these are the points. So we can decide the points. Points of constructive interference and point of destructive interference can be shown like this. Constructive interference, destructive interference, like this. So once we mark the points of constructive and destructive interference, we can decide how the interference pattern looks. What is the nature of the interference pattern? So ये अशी diagram आपल्याकडे. So in this diagram we have taken same value of lambda for circles of increasing radii. So lambda is same. Both the waves are traveling through the same water medium, therefore velocity is same. So v and lambda are same, therefore frequency is also same. So we have to use ripples having same frequency, same wavelength. Also, they should have same phase. They should have same amplitude. So such a wave are called as systematic wave. Systematic waves having same frequency, wavelength. आपल्या फिगरमध्ये आहे ती सेम फेज difference is 0 and having same frequency, same wavelength, same phase and same amplitude. Means we are using this case. A1 is equal to A2 is equal to A. Both the waves, water waves produced from A and B have same amplitude. मग अशा जर आपल्याला वेव प्रोड्यूस करायचे असतील सिस्टमॅटिक वेव आपण म्हणतो, the systematic waves having same frequency, same phase and same amplitude are produced by using the simple arrangement, and that simple arrangement is like this. I will show here. Suppose this is a tree filled with water. This is a stand, retort stand. Here is a tuning fork. Tuning fork is fixed like this. The tuning fork is kept like this. Here is a water surface, and this is a tuning fork having certain frequency. So, to one of the tuning fork, one of the prongs of the tuning fork, a pin is attached on this side, other pin is attached on back side. So one pin is on this side, other pin is on this side. So these two pins are in contact with the water surface at point A and B. The arrangement here from one pin is attached on this side, other pin is attached on this side. So these two pins are perpendicular to the surface of water. So when we start the vibration of the tuning fork, the prong will move up and down with certain fixed frequency. So these two pins will also start vibrating. These two pins, one on this side, other is on this side. So these two pins which are in contact with the water surface, they also start vibrating with the same frequency. So from point A and from point B, where the pins are in contact, the ripples will produce like this. So these ripples will have same frequency equal to the frequency of the tuning fork. They are in the same phase and they are having same amplitude. सुरुवातीला ह्या दोघी पिन जे आहेत त्या वॉटर सरफेसच्या जस्ट कॉन्टॅक्टमध्ये आपण ठेवूया. So when the tuning fork start vibrating, both the pin will move up and down with the same amplitude. So same amplitude, same phase, same frequency, same wavelength, all these conditions are satisfied. The phase difference between them will be 0. So the waves produced from the point A and B where the two pins are in contact are having same frequency, same wavelength, same amplitude, same phase. So such systematic waves are produced. And when these two waves cross each other on the water surface, at some point we will get the constructive interference shown by circle. We will get destructive interference at remaining point shown by cross. And once we decide the set of points of constructive and destructive interference, we will get the nature of the interference pattern. आपल्याला याप्रमाणे फिगर काढायची. तर फिगर काढताना पूर्ण काढण्याची गरज नाही. आपण फक्त याचा हाफ पार्ट काढणार आहोत. तर ह्या ए आणि बीला जॉईन करणारी लाईन जर काढली तर सिमेट्री इकडे जसा पॅटर्न मिळेल तसा तिकडे मिळणार. But due to the symmetry of the interference pattern about the vertical diameter, the pattern will be same. So we will draw only half part. आपण फक्त इकडचा हाफ पार्ट करणार. So A is a one point, B is another point, they are producing the ripple, and these ripples are having this property. First circle की radius जर आपण R1 घेतली तर second circle की radius 2 times R1 येईल. So R2 is equal to 2 times R1, R3 is equal to 3 times R1, R4 is equal to 4 times R1, R10 is equal to 10 times R1, R17 is equal to 17 times R1. तर आपल्या पेपरवर नोटबुक मधल्या पेपरच्या पेजवर आपल्याला डायग्राम कडे द्यायचं असेल तर R1 काय करायचं, आपल्या पेपरवर त्याच्या दोन लाईन्स आहेत. तर पेपरवरच्या दोन लाईन R1 घ्यायचे. So this distance is taken as R1. So next line it will be R2 like this. So to draw the diagram correctly in a short time with these properties, the procedure is like this. Suppose this is the line joining this A and B. So these are the lines on the paper. They are equidistance. हे प्रोसेसर एकदा समजून घ्या. या डायग्रामचे बरेच युजेस आपल्याला बघायचे. So these are the lines on the paper. They are equidistance. They are parallel like this. Their separation is same everywhere. So these are the lines on your paper. So suppose A point is marked say here. Then 1, 2, 3, 4. On the fourth line we will take the B point. So A and B point are marked like this. You try this figure. Now from point A we will get the circles like this. So the first circle is at this point there is a trough. First circle is having radius this distance between the two lines R1. So this is the circle of crust, solid circle. इथे पण तीच प्रोसिजर फॉलो करायची. This is the circle of crust. Then next circle is the dotted circle. Radius is R2. Like this. इथे पण तेच. Second circle is circle of trough. दोघीकडे रेडियस सारखेच राहील. Third circle is again a solid circle. So remember this procedure. Like this. इथे पण तेच होईल. Circle of crust. Blue color ने अपन दाखवतो. Then next is a circle of trough. Like this. Circle of trough. Sorry, this is wrong. Like this. So 1, 2, 3, 4. Yes, now it is correct. Like this. Next is a असे 4-5 circles काढायचे. 1, 2, 3, 4, 5. Fifth line. 1, 2, 3, 4, 5. So this is a circle of trough. इकडे पण करायचे. 1, 2, 3, 4, 5. R5. So like this we can draw so many circles. Now what to fix? The point of constructive destructive interference. So first we will decide the point of constructive interference using these two cases. या फिगर में त्याच्यासाठी जरूर दिलेलं आहे. Circle of crust and crust cross each other. So two solid circle cross each other. So this is the point of constructive interference shown by circle. Point of constructive interference, constructive interference, constructive interference, constructive interference, constructive interference. Circles of two solid circle cross each other, crust cross each other. पहिली केस आपण कंप्लीट केली. Now second case, trough. ये दोघे dotted circle cross व्हायला पाहिजे. This is a circle of trough. So one circle of trough. This is also point of constructive interference like this. Like this. Now these are the point of constructive interference. So this is the line of constructive interference. 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 So all the points on this line will have maximum displacement. Maximum displacement. Maximum displacement. Maximum displacement. Like this. Now the remaining points are of destructive interference. They are shown by cross. Now see this one. One circle solid, one circle dotted cross each other. So this is a one crust and one trough cross each other. So this is the point of destructive interference. Destructive interference. Destructive interference. Like this. This is a destructive interference. Destructive interference. So this is the point of destructive interference minimum. दोन मॅक्झिममच्या मध्ये एक मिनिमम मिळेल. दिस इज ए मिनिमम. दोन मॅक्झिममच्या इथे वन मिनिमम मिळेल. इकडे पण तेच होईल. दिस इज द पॉइंट ऑफ डिस्ट्रक्टिव्ह इंटरफरन्स, पॉइंट ऑफ डिस्ट्रक्टिव्ह इंटरफरन्स, पॉइंट ऑफ डिस्ट्रक्टिव्ह इंटरफरन्स मिनिमम. पॉइंट ऑफ डिस्ट्रक्टिव्ह इंटरफरन्स, पॉइंट ऑफ डिस्ट्रक्टिव्ह इंटरफरन्स, पॉइंट ऑफ डिस्ट्रक्टिव्ह इंटरफरन्स minimum. So this is the nature of the interference pattern after crossing of the water waves. What is the nature? When the systematic water waves having same frequency, having same phase, having same amplitude cross each other, then we get lines of alternate maximum and minimum displacement. Maximum displacement will be equal to R is equal to A1 plus A2. If the waves have same amplitude, then this is equal to 2A. So R is equal to 2A. Resultant amplitude R is equal to 2A. Maybe in the upward direction or downward direction. R is equal to 2A. Resultant amplitude at the point of crossing is equal to 2A. Resultant amplitude at the point of crossing is equal to 2A. 2A like this. And if the amplitude are equal, then on this line R is minimum, that is equal to 0. So resultant displacement at all this point is 0. Resultant displacement is 0. Resultant displacement is 0. Resultant displacement is 0. So these are the lines, red color, of 0 displacement. The water molecule will have 0 displacement, and black lines represent the maximum displacement like this. So we get alternate lines of maxima and minima. We get alternate lines of maxima and minima like this. So this is the nature of the interference pattern. तर एवढी ॲक्युरेट डायग्राम तुम्हाला काढता यायला पाहिजे. त्या पेपरवरच्या लाईन जर कट करून टाकल्या तर नेचर अजून क्लिअर तुम्हाला दिसू शकेल. लक्षात. सो रिमेंबर द प्रोसिजर. काय काय स्टेप्स आपण केले. आपल्या पेपरवरती मार्जिनची लाईन असते रेड कलरची, तिथे आपण ए आणि बी पॉईंट मार्क केले. ए पॉईंट ह्या लाईनवर घेतलं तर 1 2 3 4, चौथ्या लाईनवर आपण बी पॉईंट मार्क केला. फिगर चांगली यायला पाहिजे, आपल्याला समजली पाहिजे. नंतर ए आणि बी पॉईंट घेऊन सर्कल्स करायचे. फर्स्ट सर्कल सॉलिड, सेकंड सर्कल डॉटेड, सॉलिड डॉटेड, सॉलिड डॉटेड, अल्टरनेट सॉलिड अँड डॉटेड सर्कल. सॉलिड सर्कल मीन्स क्रस्ट, डॉटेड सर्कल मीन्स ट्रफ. आणि हे सर्कल काढताना ए आणि बी दोघे पॉईंट पासून काढायचे. आपल्याला हा रूल फॉलो करायचा आहे. If R1 is the radius of the first circle, then R2 is equal to double the R1, R3 is equal to triple the R1. आणि R1 जर आपण पेपरवर दोन लाईन मधलं सेपरेशन घेतलं तर R2 त्याच्या डबल करायचं, दोन लाईन घ्यायच्या, 3, 4, 5 लाईन, याप्रमाणे आपण रेडियस कंटिन्युअसली इक्विडिस्टन्सने λ/2 ने इन्क्रीज करत जाणार आणि नंतर फक्त पॉईंट मार्क करायचं. सो रिमेंबर द प्रोसिजर. या डायग्रामचे बरेच युजेस आहेत. हा एक यूज झाला टू डिसाइड द नेचर ऑफ द इंटरफेरेन्स पॅटर्न. सो व्हॉट इज द नेचर? That I will write down after few minutes. Second use, या डायग्रामवरून आपल्याला पार्ट डिफरन्सची कंडिशन पण कन्स्ट्रक्टिव्ह डिस्ट्रक्टिव्ह इंटरफेरेन्सची डिराईव्ह करता येईल आणि यंग सेक्शनमध्ये आपण ही डायग्राम पुन्हा रिपीट करू. तर ह्या डायग्रामचे 3 युजेस आहेत. टू डिसाइड द नेचर ऑफ द इंटरफेरेन्स पॅटर्न, टू ऑब्टेन द value of optical part difference for constructive and destructive interference, and it is a part, this diagram is a part of Young's double slit experiment. 3 ठिकाणी आपल्याला ही डायग्राम रिपीट करायची. So now, what is the nature of the interference pattern? The interference pattern due to the crossing of water waves consist of alternate lines of maximum and minimum displacements. Like this. So maximum, minimum, maximum, minimum, maximum, minimum, like this. So this is the nature of the interference pattern. Now, if these water waves are transverse waves, if water waves are replaced by light waves are also transverse in nature. आपण A आणि B चे दोन sources of light consider केले. A and B are the two sources of light which produces the transverse electromagnetic wave. So they will also cross each other like this. फक्त change क्या होईल? All the points having maximum amplitude, they will appear bright. So all the points of crossing on this line will be bright, dark, bright, dark, bright, dark, etc. So when we use the light waves instead of water waves, instead of maximum and minimum dispersion, lines of maximum minimum dispersion, we will get the bright and dark band. And therefore, now I will add bracket. The interference pattern due to the crossing of light waves consists of alternate lines, alternate bands of bright and dark points. So this is the nature of the interference pattern produced by the crossing of the light waves. The interference pattern due to the crossing of the light waves consists of alternate bright and dark band, like this. Alternate bright and dark band. आता इथे आपल्याला हे ब्राइट अँड डार्क बँड अशा डायव्हर्ट होतात दिसतात, लाईक दिस. प्रॅक्टिकली ह्या ज्या बँड्स आहेत त्या इक्विडिस्टन्स असतात, पॅरलल असतात, याच्याप्रमाणे त्या इन्क्लाइन नसतात. बाय सो दिस इज द नेचर डिसाइडेड बाय दिस डायग्राम, बट डायग्राम इज ड्रॉन फॉर वॉटर वेव्स. For light waves, interference of light waves consists of bright and dark bands which are parallel, not inclined like this figure, which are equidistant alternately. Why? So Now we know the value of lambda. For light, the wavelength is maximum for red, and say it is taken as 8,000 angstrom. So 8,000 angstrom means 8 into 10 raised to minus 7 meter. 8 into 10 raised to minus 5 centimeter. 8 into 10 raised to minus 4 millimeter. Like this. So this is lambda. Now what is lambda by 2? Lambda by 2 is equal to 4 into 10 raised to minus 4 millimeter. आपल्याला फर्स्ट सर्कलची रेडियस लॅम्बडा बाय 2 घ्यायची. हे जे आपण सर्कल काढलेले आहे, या फर्स्ट सर्कलची रेडियस आपल्याला 4 into 10 raised to minus 4 millimeter घ्यायची. नॉट प्रॅक्टिकली पॉसिबल. आपण साधा कंपासचा टोक जरी टेकवलं तरी त्याची साईज याच्यापेक्षा कित्येक पटीने जाणार आहे. सो प्रॅक्टिकली the wavelength of the light wave is very small as compared to the wavelength taken here. या डायग्राममध्ये आपण जी वेव्हलेंथची व्हॅल्यू घेतली त्याच्यापेक्षा लाईटची वेव्हलेंथ खूपच कमी. तर ह्या स्केलला जाऊन जर आपण फिगर इमॅजिन केली, काढू तर शकतच नाही आपण, इमॅजिन केली तर ह्या लाईन्स पॅरलल आणि इक्विडिस्टन्स होऊन जाते. सो बिकॉज ऑफ धिस स्मॉलर वेव्हलेंथ, व्हॉट इज द रिझल्ट? प्रॅक्टिकली because of smaller wavelength of light waves, smaller lambda, the interference bands are very close, equidistance and parallel to each other. Practically, because of smaller wavelength, the interference band are very close. इथं जे सेपरेशन आपलं त्याच्यापेक्षा ते डिस्टन्स खूपच कमी असणार आहे, फ्रॅक्शन ऑफ मिलीमीटर. दे आर व्हेरी क्लोज. नेकेड आयने कदाचित आपल्याला ऑब्झर्व करता येणार, ते आपल्याला मॅग्निफाय करून बघावं लागतात. त्यासाठी आपण टेलिस्कोप, मायक्रोस्कोप वगैरेचा यूज करतो एक्सरूममध्ये. सो दे आर व्हेरी क्लोज, cannot be seen by naked eye. They should be magnified either by using the telescope or microscope, traveling microscope, etc. They are equidistant, not in this figure. Practically they are equidistant and they are parallel to each other. In this case, they look inclined with each other. They are diverging. In this case, they are parallel. So, practical nature of the interference pattern now we know. Practically, the interference pattern of the light waves consists of alternate bright and dark band, which are very close, which are equidistant from each other. Why they are equidistant, that we are going to prove separately in this our chapter. Mathematically आपल्याला prove करता येईल. So this is the result, nature of the interference pattern. When light waves cross each other, the interference pattern due to the crossing of the light waves consists of alternate bright and dark band, and these bands are very close to each other, equidistant and parallel to each other, like this. Young's डबल स्लिट एक पण आपल्याला सिलेबसला आहे, त्याची फिगर पण दिलेली आहे आपल्या नोटमध्ये वगैरे. सो दिस इज द नेचर ऑफ द इंटरफेरन्स पॅटर्न. म्हणजे आपण ह्या डायग्रामचाच यूज केलेला आहे. So we have used this diagram. When the crust of the two waves cross each other, then resultant amplitude maximum. Trough of the two waves cross each other, then again resultant dispersion maximum. So in this figure, when circle of one crust and circle of one crust from another source B, they cross each other. These are the points of constructive interference. So circle of crust means solid circle. Circle of trough means dotted circle cross each other. So all the point of crossing in this diagram, where the two solid circle, where the two dotted circle cross each other, these are the points of constructive interference, and they are shown by this circle, hollow circle. When the circle of crust solid circle and circle of trough dotted circle. The point where one solid and one dotted circle cross each other, these are the point of destructive interference, they are shown by cross. So first mark the point of constructive and destructive interference and then join the lines. So all the points on this line will have minimum displacement r is equal to 0. The two waves have same amplitude, so they will cancel each other. So a minus a is equal to 0. All the points on this line will have maximum displacement a plus a is equal to 2a. So these black lines represent the points of maximum displacement, constructive interference, constructive interference, constructive interference, constructive interference, like this. And all the points on the red line are having minimum displacement 0, minimum displacement, like this. So we get alternate lines of maximum and minimum displacement for water waves, for ripples, and therefore it is called as a ripple tank experiments. So ripples are produced on the water surface in a tank by using this type of arrangement. This is the arrangement. A tray is filled with water. To the retrostand, a tuning fork is mounted like this. So two pins are attached to one of the prongs of a tuning fork. One is front, other is back. These two pins are kept in contact with the water surface. When the tuning fork starts vibrating, both the pins will start vibrating with the same frequency. So the waves produced from the point of contact A and B have same frequency, same wavelength, same phase, and same amplitude, like this. So systematic transverse waves are produced by using this ripple tank experiment. This is called as a ripple tank experiment, like this. Now we have to find the condition for optical path difference, and that condition is obtained by using these properties. Radius of the first circle is lambda by 2, radius of the second circle is 2 lambda by 2 or lambda, etc. So these circles are drawn systematically because of this point.